Hello.
Hello.
Hi.
Today's topic, in the introduction, it was either scan to 3D scanning or SolidWorks CAM or etc. Unfortunately, I cannot now present 3D scanning because it turned out that our license had expired and the machine doesn't work anymore. So sorry for that. I learned that one about an hour ago. So today's topic is going to be SolidWorks CAM. There will not be any exercise, but I will give you a demonstration, and of course, it's best if you try to follow or try to do what I also do at the same time. So firstly, what does this CAM mean? What does it stand for? CAM. Does anyone have any idea? Okay. So maybe if I start, let's see what SolidWorks Help has to say about the where is my yeah. No. Oh. Sorry, I'm now doing something which I should not be doing. So let's look firstly the SolidWorks CAM help files. What do they have to say? Why doesn't my SolidWorks CAM item work?
Yeah, I guess CAM is computer-aided manufacturing.
Yes, correct. Okay, let's see. What is the issue now with the it doesn't run here on my personal computer. I will see if I can make it run using the other computer. So sorry for the not so nice presentation. So I will try with the other computer. Does it work? I will switch to that one if it works. But like I said, SolidWorks CAM stands for computer-aided manufacturing, and I will find you an introductory video here that we can take a look, which is about specifically the SolidWorks CAM. What can it do? I will share the computer sound, so please be aware that the sound might be a bit high.
SolidWorks CAM standard is the perfect introduction into CNC milling directly from your SolidWorks model. SolidWorks CAM is available to all subscription customers and can let you program prismatic parts with ease. In this video we're going to explore how I can make the bottom half of this Raspberry Pi enclosure using SolidWorks CAM standard. To start this process off, we will first open the SolidWorks part. From there we can go and define a coordinate system to pick where the X, Y and Z direction are taken from in my part. This can easily be done by simply selecting one surface. Now that we have a coordinate system, we can then go and define the stock for this part. In the stock manager, it is simple as typing in additional dimensions to add the material to the bounding box and press select to generate the extra material. From here, we can use extract machinable features to recognise all the areas of the part that require machining. As can be seen, once recognised, these can be seen in the SOLIDWORKS CAM feature tree, where they can be edited or be used to generate an operation plan. Moving on to generating an operation plan. This gives a list of all operations that will be used to make the component. The operation plans can be edited, or by clicking Generate Toolpath will show the toolpath that will currently be used. With the toolpaths created, we can go and simulate how they will behave in graphics. As you can see, roughing and finishing passes are then cut out of the material, with them shown in different colours. We can see from the simulation the top of the model wasn't cut, so we can go into the options and add facing to be selected as an extracted machinable feature. We can then go through the process of extracting machinable features and generating operation plan without deleting what we had previously done. From here, we can drag the new face mill up to the top of the operation so that is done first. Additionally, by clicking on the operation, we can go and change key parameters such as the depth of cut. By confirming the changes, we can see these update in real time on screen. A final simulation shows the facing operation is done first and then goes on to do the rest of the machining as we intended. Another key benefit of using SOLIDWORKS CAM Standard is the ability to go and modify the parts dimensions with the toolpaths automatically updating to suit. As we can see, we have changed the standoff diameter from 6 to 7 millimeters, and as soon as we come back into the CAM tree, it will ask to regenerate the toolpaths without any additional work for ourselves. It will go on to recalculate the toolpaths to suit this new geometry. Another great ease of use feature in SOLIDWORKS CAM Standard is the ability to rearrange your operations in the tool tree. This automatically switches tool, allowing you to machine the way you want easily. Once happy with all the toolpaths that have been made, we can then go and select Post Process. This will look at the post processor selected and generate the relevant code for you to use on your machine. A great addition to SOLIDWORKS CAM is a SOLIDWORKS CAM NC editor. This will allow you to look at the posted output generated from SOLIDWORKS CAM and check it to ensure your machine is going to cut the way that you intended it on SOLIDWORKS CAM Standard. As you can see, the SOLIDWORKS CAM NC editor can also preview a simulation of the toolpath that is going to be run on the machine. In addition to this, we can also create a setup sheet. This will not only allow ourselves to see what toolpaths are being run, but the tools being used, as well as the feeds and speeds, and the time taken for each operation. Finally, if this part is to be made on another machine tool, we can quickly go to Define Machine and to the Post Processor tab and select a different post processor to use. SOLIDWORKS CAM offers a varying selection of generic post processors, and in this case we will choose a hide name control. Now the machine has been changed, all we need to do is select Post Process again, and this will save the new output file. Again, like what was done previously, this can be checked with SOLIDWORKS CAM NC editor to ensure that the posted output is what we want to machine. As we saw, this can be simulated to check the code is cutting what is intended. Thanks for watching this video, and for more information on SOLIDWORKS CAM, please visit our website at solidsolutions.co.uk.
Okay, that was in short how does the SolidWorks CAM actually work, or in more specifically, the same applies to every CAM software available. So the workflow for CAM software is that we have a 3D model of the part we want to machine. Then we use the CAM software to create the codes that control the numerically controlled machine. Now, if you remember the course from last spring, machining, what did we do there in the exercises? Does anyone remember?
Yes, we created the code for CNC machines.
Yes, how did we do those codes?
Well, using the environment provided by Heidenhain, I don't know.
Yeah. But
well, manually.
Yeah. You wrote the code by your hand. These were the exercises. Create the program to machine this and that part using some guidelines that were provided to you. I was thinking that, do you remember the basics, how it worked? What was the basic principle in the coding?
Well, we had starting coordinates, and we just moved the tool and changed it height and changed the spindle speeds.
X, Y, and coordinates, basically. Basically telling the tool to move in specific coordinates and doing the movements and the spindle rotation achieve the desired outcome. I planned that maybe we could try to do this first exercise from the last year's course, but with the help of CAM software. How does the result look like? I managed to open up another Zoom session, and this computer has a working SolidWorks CAM, so I will switch my presentation to the other computer, but unfortunately this computer doesn't have a mic, so I have to use this laptop's mic and sound to give my presentation, but hopefully it will work out. Okay, so now you should see my screen and hear my voice, even though they are coming from different computers. Or are you?
Yeah, it works fine.
Okay, yeah, thanks. So let's begin our example by modeling. Okay, there's some problems with this computer, but let's see. By modeling this very part shown in the drawing here. So I will start, for example, on top plane and model the part there. It's a bit difficult because this bar is on top. What's there? Okay. I don't know how could I hide that one, but it's now there. So then give the dimensions, width of 125 millimeters, height of 160. The thickness of the part is 6 millimeters, so let's put the thickness of thickness of 6 millimeters. It's best if you plan to use SolidWorks CAM and your part has holes in it, like shown here. There's 4 10mm holes. It is best practice then to use Hole Wizard, because it has a benefit that all the holes made by the Hole Wizard are recognized as holes, as drilled holes in SolidWorks CAM, which means that it can automatically select the corresponding work cycle for the drilling operation. So let's add the holes 4 times 10 millimeters. One, 2, 3, and 4. Then add the dimensions and make it as per the drawing. Okay, well, the dimensions were given like that, so maybe let's do it the same way with the ordinate. This is 15. That's 50. 85 and 120. And from the other, it's 15. So those are the holes. Next up, make the groove. Let's make a new sketch. And for this kind of a shape, if you want to make a groove in SolidWorks, you can draw the center line and then use the extruded cut with a thin feature, and it's possible to make the cut basically with the center line. Okay, I note that maybe my hole placement was incorrect, so I will fix that one. Thank you. But anyway, let's see how this could work if I only draw the center line of this shape. Okay, let's of course add the dimensions once again, and I will use the same ordinate dimensions for this one, for there, and there, and then another one from here. I have to select it again for that one and for that one. When using this ordinate dimension, notice that it doesn't automatically allow you to, or it doesn't automatically jump to the dialog where you can change the values. Those have to be manually done afterwards. You have to be careful there. And this is 24, and this has to be 120. Now, when I select the sketch and select extruded cut, notice that if I select this thin feature, I can do as it automatically makes the cut with a certain thickness. If it's selected as one direction, it's from the line that you draw 10 millimeters outwards. If I select mid plane, then it's the center line. And the thickness of the cut is obviously the same as in any type of extruded feature. I will fix this, that one. Anyway, what is missing is the fillets from the machine shape. Why does this have to have a fillet? These outer corners. What's the reason for the fillets?
Because the tool itself is round.
Correct. Imagine that our milling tool with diameter of 10 millimeters once it's moving here on this groove, it will leave a fillet there. A sharp inside corner in a groove like this is impossible to make with a milling cutter. Outside corners, sharp outside corners are not a problem. But inside corners usually are features that cannot be machined. In the CAM, if you are making a CAM model or using the CAM, what the CAM program tries to do is try to exactly copy the shape that you have modeled there. So if I have a sharp corner there, the software tries all the tricks that it has available to make the sharp corner actually sharp. That's why you need to add also the fillets here. So let's add a fillet with radius of 5 for all the sharp outside corners here. Like so. Okay, now the model is ready. I will save it. And let's look at the SolidWorks CAM. The SolidWorks CAM should be available in all the SolidWorks versions. All the SolidWorks subscriptions should have the SolidWorks CAM. But for my own personal laptop, for some reason, I wasn't able to make it run.
Sorry for interrupting you, but what about inside corners of the groove? Shouldn't they be filleted?
Like I said, it's not a problem to machine such a corner.
Oh, so sorry, I just missed it. So we'll leave it inside corner. We'll leave it sharp.
This can be sharp.
Okay.
It's not a problem. It's not a problem to machine a sharp corner inside sharp corner.
Okay.
This kind of outside sharp corner is difficult. Or however they are called. In this case, the outside corner is difficult.
Okay, clear. Thank you.
Anyway, I was saying that the SolidWorks CAM is enabled from the add-ins. For those who are using the SolidWorks on your own personal laptop, can you say, do you have this option available? Or are all of you using the virtual desktop version?
I have it in my personal computer.
Okay, good. And it works?
Yeah.
Yeah, okay, good. So it should be possible to make it run. Remember that active add-in means the add-ins currently used, and startup add-ins means those that if you have selected here a tick box, it means that it will automatically open up every time you start up your SolidWorks. Okay, where can you access the SolidWorks CAM is here. There is a toolbar called SolidWorks CAM. And how this works is, first of all, we need to define what kind of a machine do we have. So start by defining the machine. I will increase this bar because it's these are related to the SolidWorks CAM and we will need them soon. So I will expand this feature tree a little bit. So let's start by defining our machine. So now it opened this machine definition bar or dialog where there are a lot of information about the machines. We can firstly define the type of machine. I will use the default milling machine in metric units. Then we could define our tool grip, what kind of tools we have available. Once again, I will use the default one. Here I can select the post processor. The post processor is important because what we do here in the CAM is we are only working inside the CAM software. We can define how we want to machine our part, what do we actually do, etc. And after we are finished in our CAM software, the next step is to convert all the information you did on the CAM software to a form that the actual milling machine or lathe will understand. And that is done by the help of post processor. The post processor will convert everything that you defined in your CAM software to the language that the actual machine understands. And that's why there are many of these post processor types for different machines and for different controls. There should be, for example, this Heidenhain TNC 530, which is pretty close to the TNC 620 that we used in the machining course. So I will select that as my post processor. It should make the actual code easier to read.
Excuse me.
Yes.
Why does my computer doesn't have like the solid CAM tabs? It shows in add-ins that I have add the solid CAM, but like in the tab there's no add-ins. No, there's no SolidWorks CAM. Yeah.
So you are not able. If you go to the add-in, yeah, and now happened something. If you go here, you select active add-in as SolidWorks CAM. You click here.
Wait. Yes.
Then you click OK,
Yes.
and you don't become the SolidWorks CAM or SolidWorks CAM DBM. These do not appear.
Yes.
Okay, now go back to here, add-ins, and is there a checkbox now in here or not?
Yes, there's checkbox.
Okay. Exactly here that it is active.
Yeah.
Okay, so it should be working. What if you add a tab here, tabs? Can you find the CAM here?
No.
How about toolbars? Do you see these CAMs? CAM.
Yes, in toolbars
Okay.
there is some.
Then select one of them. For example, this SolidWorks CAM. Now the information is here.
Oh, yes.
But it might be a little bit difficult if you cannot enable the tab here, this SolidWorks CAM tab.
I remember like in the past I have that tab, but like now it disappeared.
Well, okay. Maybe we continue with the machine definition here, so we get moving. Anyway, I was left here as the post processor. So the post processor is the part of this CAM program that is able to actually write the NC code, because in the end we are producing the same coding that we were able to do by hand. The only difference is that we don't actually write any part of the code. The machine does it for us. Okay, after you have defined your machine, next one, define your coordinate system. So remember that on milling, the tool is most likely always on the z-axis. And now, by the definition of my modeling, my z-axis is pointing this way, which is not correct at all. I want my z-axis to point up. So I will select it by user-defined method, and I want to put my origin right there. I selected this point here. Now I want to define my x-axis as this axis, y-axis. Oh, sorry. Y can be this one. And I will reverse the x and y. So now my origin is here. X is pointing that way, y is pointing that way, and z is pointing upwards. Okay, are you still following?
Yes.
Okay. Yes, okay, let's move on. So now my coordinate system is defined. Next up, define the stock. What is the stock that this part is made out of? Because the part to be machined isn't necessarily the correct size already. In the stock manager, we will tell what is the part originally, what is the size, what type of a part we originally have. Here I could also define the material if I want. Well, I will put this as a steel. Sorry, these are markings for American standard steel, so they might be a little bit difficult to understand, but this 1005 is the common mild steel, so I'll select that one, low carbon alloy steel. And here I could select add the offsets for my workpiece if I want. But okay, let's leave them like that. So now I have my stock defined, my machine is defined, my coordinate system is defined. In SolidWorks CAM, there is this feature called extract machinable features, which automatically generates all the features that can be machined from this part. It will automatically generate the those features that it can recognize that, okay, I can do these parts. Most likely it cannot do everything in the part. But let's see what happens once I click this one. So what did it recognize? It recognized that we have a pocket here and we have a hole group. There's one hole, there's another one, there's third, and so on. So now we know what kind of features we have here. And the idea here was to create a program that can machine the pocket and the holes. So basically, the automatic feature was quite successful in this case. The next step in this SolidWorks CAM is to generate so-called operation plan. In this first step, we were able to recognize that, okay, we have these features in our part. Next step is to generate some kind of operation plan. How do we do actually those features? So this is once again automatic. So let's see what happens once I click it. And now it created me an operation plan with the actual tool parts quite soon. So now I have operation 1, rough mill, and another rough mill operation, I don't know why. Then a third milling operation for some reason. Then center drill operation. There might be some errors. What's wrong? Let's see. Okay, it's using a tool that is not in the tool grip. That's not a problem. We can add the tool in the tool grip. And finally, a drilling operation. Here, I can rearrange these. So I want to first drill the holes. And after that, I want to mill the pocket. At this point, it hasn't done any tool paths yet. The tool paths are made once I click this generate tool path. And now it actually created the tool path for all the operations. Okay, let's see how this looks. If I simulate my tool path here, let's see what happens. I want to turn down the speed so it doesn't go so fast, but let's see what happens. Okay, now it's center drilling the first holes. Then it will switch another tool and drill the holes. Okay, now it starts to machine the pocket. And I turn my, no, I cannot. Oh, now it's moved. I will speed up a little bit. I don't know what it is doing there. Why is it mashing also the surface not to be machined? So sometimes this automatic feature recognition doesn't really work the way it should work, because that surface should not be machined. Now it's working on the corners. Once again, I don't see the point why. Now it's doing the final pass.
Can this corner work be due to the these lines in between the corners? Like feature produces these lines so it doesn't look like a smooth surface.
No.
I don't know if you understood me.
No. Anyway, it seems that for the holes, the automatic feature was quite successful, but for the pocket, it wasn't really successful. This is way too many steps to machine a simple shape like that. We can take a look at the code. If I click this post process, it will write me the code and save it somewhere. I will save it there, and let's look at it. How does it look? Okay, it wrote the code. Do you want to guess how many lines there are? If you remember the exercise from last year, can you remember how many lines this exercise was about?
20.
About 20. How about the NC version, or the SCAM version? How many lines?
Some hundreds.
Sorry?
1 or 200.
Yes, let's see. So, it starts with the definition of the form, but okay, it doesn't really make it the way it should make. Then it starts to do something. And after 494 lines, it is finished. The reason being that most of the movements here are linear movements, meaning that it will move the tool accordingly. And in CAM software, you can do it like this, because you don't have to manually write all the lines here. But if you look at the code here, doesn't it look pretty much the same as what you would do manually? Let's see, this is, for example, the, the part for where it is spot drilling the holes. So we position over the first hole, then to a safe distance, then define the cycle, then use the cycle again. So in theory, in some sense, this is quite clear what happens.
I don't really understand. What are those lines with just, I don't know, dot and comma?
This means this is this comma.
Well, I don't remember how do you say this, but
these lines that have these is this called comma? This symbol, this one means that they are comments. So they are actually not.
Oh, okay.
So we can write here that what happens.
This is quite a strange way to make comments, but
yeah,
great.
But it works in the control so that this line is neglected if it has this comma symbol.
Yeah.
It doesn't try to do a command called 10mm chopper drill, because then the control would be kind of clueless what to do.
Did you teach us how to make comments in G-code?
Maybe I showed, but I didn't. It wasn't extensively used, so maybe it was missed.
Okay, thank you.
But it's just basically adding that marking there. Then you can write what happens, for example, on this line. I could write here that linear movement. Y. And that would work in the actual machine. Comments are useful, for example, here in the beginning of this CAM program. Notice that we can write for example, the initials of the programmer. It can be given in here in the program itself, etc. But as you notice that the CAM programs will tend to be very long easily, because they are not so straightforwardly created, because the computer will do them. Once again, if we imagine how did we do this one last year, machining this pocket. It was done so that we selected a 10mm roughing end mill that is able to machine a pocket with the width of 10mm easily. with a single pass, so that if we program our tool from this point to that point, from this to there, and from here to there, and there, we end up with the desired pocket. What happened in my CAM program is that it selected a 6 millimeter flat end tool, which means that if you want to create a 10 millimeter wide groove with a 6 millimeter tool, it means that you have to go twice. One times the inside, one times the outside. Moreover, it does this one in 2 passes. So it first removes 2 millimeters in thickness and then another 2 millimeters on the second go. So that's why there are so many more lines on the code. Moreover, for some reason, it selected that we want to also machine this island here this surface was machined, even though the tool wasn't touching the surface. Then for some reason, it starts to work on the corners. Only these small portions here are machined. I don't understand why. And finally, it's doing this final passes of the shape. We should be able to edit our definition. So if I right-click here, edit definition. And let's see if I could change our tool so that I would use a 10 millimeter tool. So let's see if I somehow can select a 10 millimeter tool, this one. I want to select it. Yes. Now my tool is 10 millimeters for the operation. Under F and F/S, it stands for feed and speeds. Here I can define my feed either from the library or what happens now? I don't know. Or I can also manually somehow edit these. I can either select the surface speed of the tool or use a spindle speed. Same thing for feed. I can define feed per tooth and the feed rate. Of course, they depend from the tool. On the control, I can define how the machining actually takes place and so on. There are a lot of parameters that you can define here. And I mean a lot of them. But let's see, I should be able to get to my screen is too small. How do I click the OK symbol here? The OK symbol is right here in the bottom, but I cannot access it. It doesn't go there. Does anyone know how could I click the OK, which is hidden under this bar? Or is it? No, it's not there.
I would recommend you to drag the window up. Yeah.
But it doesn't. It doesn't go. I cannot do it.
Or try to access its top left edge. Yeah, and resize it. Is it possible?
No.
Mm.
Is it possible to drag the window to beside, like to right or to left?
No, I only have this one screen here.
Try to press
I-
enter.
Yeah, that one. You
Okay,
erase.
maybe. I pressed enter.
Oh, great.
Thanks. So now what happened? Let's see. I generate the toolpath again. Oh, sorry. And it doesn't show any toolpath. The problem here in SolidWorks CAM is that it doesn't recognize how to do such a feature. I can work my way around it. If I make this cut a little bit wider, if I make it, let's say 10 point, like so, then it should be able to make it. At least previously it has worked. Doesn't look very promising. No. Let's make it even a little bit wider. Okay, seems that I cannot make it the way I want to make it.
Is that possible to change the tolerance so it won't use the smaller for precise one?
I can try to manually do the toolpath I want to make. So I can select here 2.5 axis mill operations. Here I can select that it's a contour mill. I want to machine a different type of contour. Then it has recognized this feature. Okay, let's machine that one. Select the tool again for the new operation. No hello ones, no nothing. Yes, I want this to be used and select OK. Generate toolpath. No, it doesn't work. For some reason, this is sometimes a little bit complicated to get it actually work the way it should work, or the way you want it to work. If I change here the 10 millimeter mill, what happens? Let's see. Okay, this one it's able to do with 10 millimeter mill. Let's see the toolpath. Not this one. I will delete the ones that didn't really work. Let's see the toolpath simulate. Okay, now it's only working the corners. Why? Then it starts to machine that one. No, that's not what I want to do. What if I now change this one a little bit bigger? Let's make it now 10.05. and still it doesn't want to cut this big groove here. For some reason, the CAM software doesn't want to cut grooves directly with the end mill. It always wants to make them in one pass for the other side, one pass for the other. But overall, once you get hang of this software, it's quite useful. The main benefit is, okay, if I return now to the original state where I had this. All features defined here, and let's make the toolpaths. So now we are back in the original state where it was making all of this. So the benefit of CAM programming is that if I make a change now to the model, let's say I want to, this needs to be, this is going to be 140. In SolidWorks, it should automatically recognize the change. I didn't exit my sketch. That's the reason why it didn't ask anything. I will do it again. Now, once I go back to the SolidWorks CAM, it should ask, the CAM data needs to be updated. Do you want to update the CAM data? Well, yes, you want, because the geometry has changed. And respectively, also the toolbars should now follow the revised geometry. If you add features here, those might not be automatically recognized. Or I mean, they will not be, of course, updated because they are not first recognized. I don't understand what is it doing there, because it's not machining anything, and that surface should not be machined at all. The tool is not touching the surface. Why is it making those moves there? But anyway, that was a short demonstration of the capabilities of SolidWorks CAM. Obviously, the part wasn't very difficult, but the more complex the part is, the more benefits this SolidWorks CAM will have. For simple parts like this one, I would prefer that manually create the program. It's much faster, much easier to work with, much shorter. But if the part has difficult geometries or it has a lot of features, then prefer the CAM. For the lecture today, I think this is enough. Is there anything you would like me to answer or explain or anything like that?
Can I ask that even when we did not tell the SolidWorks CAM about the drill, it will automatically add it to the tool, like in your feature?
Yeah. It gave me the error that okay, this tool is not in the tool grip, but I will use it anyway. It gave me an error message at some point. Okay, notice that this tool wasn't part of the tool grip that was in use, but we can still use it.
And Ivo, you told us that next week is the exam, right?
What?
I think that the last week you told us that the exam is the next week. Maybe.
No, not next week. On week 17.
Oh, in 2 weeks.
But we can take a look at, for example, the exam right now. Or if I put it always, or visible also for you at the same time. So let me share my screen. So the exam is an online exam, which will contain 25 statements of technical drawings. They can be true or false statements, multiple choice questions, numerical exercises, whatever. They are randomly selected, and you have to answer one question at a time. In general, each of the questions only has one correct answer. In some cases, there have been some, let's say, opinions that maybe there could be more correct answers, but those can be addressed if you present such a. If it's unclear, then I can judge them again. You can use all the material available, but not your friend. This is an individual exam, like all the other exams. If you answer wrongly, select the wrong answer, it doesn't reduce any points.
So it's 25 questions, and we have a limit time. I mean, for example.
Yeah, the time limit was. Is it said anywhere? No, I have to see. Oh, I have put it. Sorry. I have put it. Maybe I will put it for the week 17 instead of the lectures. Do it on the lectures. It's more clear then. So it's on the lecture on the week 17 lectures, 27th of April, not May, but April.
And it has to be during the lecture, or it can be in another time.
Do it during the lecture. It's easier for me and for you. Then it's over after the lecture is finished. But there will be no lecture in the Zoom, so you don't have to be in the Zoom during the exam.
Okay, it's only because I don't know if it's overlapping with other subjects, so I will tell you if it's the case.
Okay. But as for now, it's during the lectures on week 17. So
okay.
Time should be correct. 27th of April from 10:15 to 12 o'clock.
Okay, great. Thanks.
Anything else related to the exam? Remember to complete all the exercises. The sooner you complete them, the easier it will be for you, because I guess there are quite a lot of other exercises also to be completed in the latter parts of the or other courses. Okay. If there are no further issues or questions or anything, then I think we are finished for today. So have a nice end of the week. Bye.